Hi everybody, this is a review of the review sheet that you did with all the answers. So hopefully you spent some time on it, you had your rules out, and you make sure that you know these rules. When you're taking the test, of course, you can use your rules because I'm not going to be there to say that you can't use your rules. So take your time, use pen, use paper. You can see how I have stuff highlighted on here. For those of you on Google Classroom, I still have a few more people to get on there, but I'm posting stuff as an assignment. So if you would like to, turn it in once you watch the video or once you get the review sheet or whatever you do, then that would be great. Anything that you do for homework or this review sheet, if you turned it in before I gave out the answers, then you can do that for extra help. So here are the answers for the Unit 9 Circle Review. You are going to be able to start your tests today because today is Friday, although I'm doing this video a little bit earlier. But today is Friday for you guys when you're watching this, and you're going to start your test. There are two parts to it. One is on Delta Math, and you're going to do those questions. The way that Delta Math works is that you are going to first make sure that you make an account. But when you do a problem, there's a little button there that says show an example if you're not sure how to do something. If it's not a multiple choice question, then you'll get another retry to try and do the problem. And basically, they're just going to keep on asking you the question over and over until you do get it right and so that you understand. All right, so use those examples. And the second part of your test is going to be a link to a Google form. So both of those together will equal your test grade. And you have until Tuesday at midnight to do that. If you have any problems at all, please send me a message, mind, or email me and let me know, if something's not working right or something's going on that I should know about. All right, so here are the answers to the circular review. Question 1 wants to know which is not an example of an inscribed angle. See how I highlighted the word not right there? An inscribed angle has its vertex on the angle and it's the sides of the angle are chords. So I highlighted in red this angle right here, NST. That is not an inscribed angle. Sort of kind of looks like one, but it's not an inscribed angle. All the other three choices were inscribed angles. There's also a hard copy of all this that's on the link as well if you prefer to look at that in addition to this video. So in number 2, we have that AB is parallel to radius MC. Because they're parallel, since I know that this angle right here is 52, then this angle right here is going to be 52. And since this angle is 52, these are alternate interior angles. That makes this arc 52 right there, but you're actually trying to find this arc right here, CD in purple. And together, these two arcs form a half a circle, so that's why I did 180 minus 52 equals 128. Okay. Number 3, I have some isosceles triangles going on in number 3. So they told me that this angle right here, where my cursor is 26. The yellow triangle is isosceles because those are both the radius of a circle, so that makes this angle 26 right here. They also told me angle LMN is 98, so LMN is right here, LMN. So it's these two angles together is 98. I wrote the 98 out here. 98 minus 26 is 72, so that's how I got this right here to be 72. And once I know this is 72, then I know that's 72 because this green triangle is also an isosceles triangle. These are both radiuses. And the angles of a triangle add up to 180, which is why I did 180 minus 72 minus 72. The nice thing about these videos is that you can stop me, you can rewind it if there's something that you missed. All right, so take your time and go through this however you would like to. I wrote for question 4 is technically a flawed question. If you draw the picture like I've drawn it here, the answer is choice 4. You're looking for a statement that does not have to be true, and they just say that A, B, and C lie on circle E. If I put A, B, and C this way, though, technically all the choices are not correct. But I think this is the way they intended the picture to be, so therefore it would be choice 4. Question 5 has circle K. I have a radius of 8. AKC is a diameter, so that makes this 8, and then this is 8 right here, so that diameter is actually 16. Point F is located on the circle. FC right here is 6. And remember, anytime I have a circle, a triangle rather, inscribed in a semicircle, it has to be a right angle. a right triangle. This angle F right here is an inscribed angle, and it matches up, it intersects this arc, which is a semicircle. Since the semicircle is 180, that's what makes that a right angle. Since it's a right angle, then I just use my Pythagorean theorem in order to find that missing side. This right here says x. It's hard to read that number. I'm just looking at that now. So x squared plus 6 squared equals 16 squared. I use the Pythagorean theorem and I solve. You can see all my answers are in decimals, so I just took the square root of 220. Okay, so that's the first page. Second page right here, I want to know which two angles do not have to be congruent. So the first choice A, these are actually vertical angles, so that's why they have to be congruent. And 2 and 4, EFH and HGE. So EFH, that's this red one, where I have the green dot. And then HGE is where I have this other green dot. Both of these are inscribed angles. They match up with this arc. So since they have the same intercepted arc, they have to be congruent. And choice 4, FEG, which is this black dot, and FHG, which is this black dot, these are also inscribed angles that match up with this arc. Notice I made the arcs the same color, so they have to be congruent also. The ones that don't have to be congruent are EFH and GHF. So that's question 6. Question 7, measure of arc ABC. That's what I highlighted in this purpley color is 262. Remember, all of the arcs in a circle that make a complete circle are 360. So 360 minus 262 is 98. So that's why the green one is 98. And I'm trying to find this angle right here that I have outlined in red. That's an inscribed angle, and it's half the arc. So that's why it's going to be 49. Okay, so the hard copy that I have linked that you can also download or look at, that has some more work on it. So if that's helpful to you, you can look at both of these. Number 8, opposite angles of a quadrilateral inscribed in a circle have to equal 180. So that was one of the rules that I learned. They gave me this angle right here is 65 and this angle right here was 80, and they want me to find the angle that I have outlined in red. It's opposite this angle E right here. Together those have to equal 180. So all I did was 180 minus 65. That's how I got the 115. Okay. And this next one right here, they tell me that these chords right here are parallel. DE is parallel to AB. Therefore, see the arcs that I have highlighted in yellow? Those have to be congruent to each other. They told me this arc that I have highlighted in green is 104. So all I did was 180 minus 104, that's 76. But I divide it by 2 and I get 38. So that's how I find out these arcs that are highlighted in yellow are 38. And then I want to find angle EDB, which is right here. That's going to be 19 because it's an inscribed angle. It's half of the arc, and half of 38 is 19. And the thing that they actually want me to find is ADE. So this is 90 and this is 19, and I add those together. Okay, how do I know that this is 90? Is that the rest of this is 180. It's inscribed, it's a triangle that's inscribed in a semicircle, has to be a right triangle, that has to be a right angle right there. Number 10, I'm trying to find angle RWQ. That's what I have highlighted in red right here. That's not a central angle, it's not an inscribed angle. But remember the rule, when I have an angle that's inside a circle, the rule is the angle is 1/2 the sum of the arcs. So the problem in here is that I didn't necessarily have all the arcs. They told me that RS is 131, so this was 131. And together, everything I have highlighted in blue is a semicircle, so it has to equal 180. So that's how I figure out that this arc right here is 49. And they gave me ST over here was 21. So again, it's 1/2 the sum of the arcs, and that's how I get the arcs. And half of 70 is 35. Okay, again, stop at any time if you need to rewind, if you need to listen to it again, if it's going a little too fast for you. Number 11, when I have two chords that intersect, the chords are not the same length, but the segments of one chord multiply equal the segments of the other chord multiplied. and they told me that chord CD is bisecting AB. So see this AB that I have in yellow? It's being bisected. So I don't know what each part is, but they're congruent. So I just call this half X and this half X. So basically the two segments of one chord, X times X, equal the two segments of the other chord, 4 times 10. So X squared equals 40. I take the square root of that, and then I just simplified that. All right. And they wanted me to find AB. So after I find out that one of these is 2 radical 10, X is 2 radical 10, I do have to double that or multiply it by 2. That's why my answer is actually 4 radical 10. 12 looks a little confusing, but one of the rules I have to remember on 12 is that when I have a tangent, which is AB, and this radius right here, CO, they're perpendicular, so they're going to form a right angle. They also told me in the given that AO is perpendicular to OB, so this is a right angle that's right here also. So the first thing they told me was angle B was 36. This is 90, so all I did was subtract 180 minus 36 minus 90. That's how I got the 54 right here. And then once I know that angle A is 54, and this is a right angle, I can subtract these two from 180, and that's how I get this 36 right here. And that's what they're asking me to find, is this angle. We've done problems like 13 before where the arcs are not given to us, but they tell us the ratio of the arcs. So the ratio of all these arcs are 2 to 2 to 1. So the first arc is 2x, so AB is 2x, BC is 2x, and CA is 1x. And you can see I wrote those in purple around the picture. Together they form a complete circle, so that's why they equal 360. I solve for x. I get x equals 72. Then I go back and I substitute to find all these arcs. So 2 times 72 is 144. 2 times 72 is 144. And this is just x, so this is 72. And the question they want me to find is this green angle right here, angle CAE. It looks like an inscribed angle. It's not an inscribed angle, but it actually has the same exact rule as an inscribed angle, and that it's half the arc. So half of 72 is 36. Number 14, angle P is outside the circle. Remember, anytime that we have an angle outside the circle, it's 1/2 the difference of the arcs. So the thing on this one is that I'm missing some of the arcs that I'm going to have to find. They told me that this arc right here, AC, is 130, which I actually don't need, but I'm going to need it to find the other missing arcs. This arc right here is 62, and I don't have this arc. I need the 2 blue arcs. I'm missing this blue arc. But together, all 3 of these equal 360. So look what I did. To find arc BC, 360 minus 130 minus 62, and that's how I get 168. And then again, to find angle P, which is what the question's asking us, angle P is 1/2 the difference of the arcs. Which arcs? The arcs that are between the sides of the angle. So those are the arcs that I have highlighted in blue right there. Okay. Number 15. I have 2 tangents right here, and I'm trying to find angle M. Angle M is outside the circle. Anytime I have an angle outside the circle, the rule is that it's 1/2 the difference of the arcs. The problem is they didn't give me the arcs. They told me this arc is 156. I need this arc right here. Well, together they just form a circle. So 360 minus 360 minus 156 is 204, and I do 1/2 the difference of the arcs, 204 minus 156, and that's how I get 24. Oops, I lost my screen for a sec. All right, and then if I go to the next one, number 16, I have a secant and I have a tangent. Remember, the whole times the external equals the whole times the external. So the tangent is the whole thing and the tangent is the external. So that's why it's x squared. The whole thing is 10 right here. And the external part, that's the part sticking out of the circle, is 6. So 10 times 6 is 60. Then I take the square root of 60 and I simplify it. So basically I'm saying 4 times 15 is 60. The 4 is a perfect square. That's why it comes first. And the square root of 4 is 2. Equations of circles. This circle's already graphed for us, so we need two things to write the equation of the circle, the center and the radius. The center is -2, 3, and the radius, I just count the length of this line. That radius is 6, and then I write my equation. So basically, I can get rid of choice 2 and choice 4 because they have the wrong radius right there. And remember that when I'm writing the equation, the numbers next to the x and the y have to have the opposite signs. So that's why it is x plus 2 squared plus y minus 3 squared equals 36. On number 18, I have to complete the square in order to put this in standard form to find the radius. So my equation is in purple, and then in red right here is what I needed to add to complete the square. So half of -8 is -4. -4 squared is 16. So I'm adding 16 to this. Whatever I add to the right, whatever I add to the left, I have to add to the right. Same thing with the y's right here. Half of -2 is -1. -1 squared is 1. So I add 1 to the left, I add 1 to the right. Now I actually don't need to finish this on the left. I did finish it. But if I add 33 plus 16 plus 1, that's 50. Okay, and then that's my radius squared, so my radius is the square root of 50, which is 5 radical 2. Now, if they asked me the center, then I would have to complete this. I don't, but that work is there for you if you wanted to see it. Number 9, I have a circle that has a center, and they give me one of the points, and they want to know what would be the slope of the tangent line drawn at this point. So remember, a radius and a tangent are perpendicular. So all I did was I found the slope of the line that connected the center and that 0.86. So the slope is y minus y, 6 minus 2, over 8 minus 5. So my slope is 4/3. And my tangent line is perpendicular, so I have to flip that and change the sign. Number 20 is an isosceles triangle. So once they tell me that this angle right here is 34, that makes this angle over here 34, because they have to be congruent since these two blue lines are congruent. So I find this angle here, it's part of a triangle. A triangle adds up to 180. So 180 minus 34 is 112. If this angle is 112, they actually want me to find this arc that I have in the purple color, and 1/2 of that arc equals the angle, so I'm actually multiplying that angle by 2, so that's where I get the 224 from. Okay, next page, I have a right triangle because I have a tangent and a radius, and they want me to find angle Q. I can't use any of my circle rules. I'm actually using trig to do this. So if anytime you have a right triangle and you're trying to find an angle and you have the other two sides, I'm going to use trig. This is opposite and adjacent, so that's why I'm using tangent. Remember, when I don't have the angle, when the angle is the thing I'm trying to find, that's when I do that inverse button on my calculator in order to find the angle. Right? On 22, again, I'm using trig because I have a right triangle that's inscribed in a semicircle, so this is a right angle, and I'm trying to find the length of chord LN. So I'm going to use cosine because I know this right here. This is 8 and this is 8. Well, they tell me the radius is 8, so I'm just going to double that 8 and 8. So that whole hypotenuse is 16. How did I get this angle? They told me that this arc is 56, so therefore that angle, that's an inscribed angle, is half the arc. So cosine of 28 equals x over 16. It's adjacent over hypotenuse. I cross multiply and I solve. Okay, on the website is a link, cimath.com is a link that you can download a calculator if you need one. Those of you who have Android phones, a lot of you already downloaded that app right onto your phone, which is great. So this one right here, number 23, I said that you can skip because part of this picture is missing right here. So I did do it. You can see what the answer was, but it was kind of hard to figure out since you were missing the bottom part of that picture. 24, the rule is anytime you have an angle inside the circle, it's 1/2 the sum of the arcs. So it's just going to be 1/2 of 64 plus 140. The problem, I guess, is that you didn't have this 64 right here. So this arc that says 64 got a little smushed in there. This angle they told me in the given is 32. That's why that arc was 64. And again, an angle inscribed in a circle that's not a central angle is 1/2 the sum of the arcs. Which arcs? The angle is the blue angle, so it's the arcs that are on either side of the angle, opposite the angle in both directions. So this 140 and this 60, the ones that I have outlined in red. This they want me to prove why these two triangles are similar. In order to have similar triangles, I need angle, two angles. Angle 1 and angle 2, this is the easy part. Those are vertical angles, so those are congruent if I was doing a formal proof. And then these angles H and G, which I have, those are both inscribed angles that match up with the same arc. So they're congruent because both intercept arc HG angle, yeah, they both intercept the same arc. Okay, and therefore my triangles are going to be similar to each other by angle. All right, flipping over to the next page. Basically, because this is a tangent and a radius, that makes these lines perpendicular. So CD is perpendicular to BD and CA is perpendicular to BA because a tangent and a radius are perpendicular. That makes angle 1 and angle 2 both right angles because perpendicular lines form right angles, and those right angles would be congruent to each other. CA and CD are also going to be congruent because they're both radii of the same circle. They share BC right here, so I can actually prove that these triangles are congruent to each other by hypotenuse leg. And then if they're congruent to each other by hypotenuse leg, then BD has to be congruent to BA by CPCTC. 27, the arcs HQ and QR and RJ, they all form this semicircle right here. So together they add up to 180. So remember, we're just going to call the arcs 2x, 1x, and 1x. I write an equation. I set them equal to 180, and I solve, and I get 4x equals 180. X is 45. And I'm trying to find angle S. Angle S is outside the circle. It's 1/2 the difference of the arcs. Okay, which arcs? The arcs I have in red. So this one was a semicircle, so that's how I knew that was 180. And this one, QR, was just 1x. So once I found out what x was 45. That's why I did the 180 minus 45. And then, of course, I take half of that. 28 has a couple parts to it. So the first part is I want to find the measure of arc BC. So arc AD and arc BD. So AD and BD, those are right here. That's what I have outlined in purple. Together, those form a semicircle, which is 180. Let me just see what I did here. I'm trying to determine the measure of arc BC. So I don't think I wrote it down what I actually did, but 2x plus 1x, I have it on the sheet that I printed for you that you can click from either the website or the Google Classroom. But 1x plus 2x equals 180. See how I have the 180 right here? So the x is 60, so this angle right here is 120, and this angle right here is going to be 60. All right, and let me just see, determine the measure of arc BC. So I'm trying to find this angle right here, this arc rather. So angle F, which is here, it's outside the circle, is 1/2 the difference of the arcs. So this arc right here is 180, and then this arc right here is 76. All right, so, well, actually, I don't know the angle. I don't know the arc. I know angle F is 52. I went ahead of myself. So angle F is 52. It's 1/2 the difference of the arcs. I don't know the arcs. It's 180 minus 1x. To get rid of this half, I multiply by 2, so that's how I got the 104. And I'm solving for x, so I need to get x by itself. So I can bring the x over here and make it positive and bring the 104 over to the right, and that's how I got the 76. Then I want to find the measure of angle AEC. That's where I have the green dot right here. So it's inside the circle, but it's not a central angle, so it's 1/2 the sum of the arcs. And my arcs are 104 and 28, the ones that I have in green. So I did this part of the problem all in green. All right, so you can see that. Number 29, I'm trying to find segments formed by a tangent and a secant, so it's the wee. The whole times the external equals the whole times the external. The whole thing is 8. The external part, the part sticking out of the circle, is also 8, so that's why it's 8 squared. The whole thing is 4 plus x, because I call the radius x right here, so it's actually 2x plus 4 is that whole thing, and the external part is 4. I distribute that 4 to everything inside, and that's how I get the 8x plus 16. I subtract 16, I divide by 8, and that is my x, and x was the radius of my circle. Next one, number 30, you need to find the center and the radius of that circle so I can complete the square. I started everything in purple was the original equation, and then you can see in red is what I added on to each one. So I take half of -6 is -3, -3 squared is 9. Add 9 to the left, you must add 9 to the right. Half of -2 is -1, -1 squared is 1. So you add 1 to the left, you add 1 to the right. All of this together equals 8. This is now a trinomial. It's a perfect square. It factors to x minus 3 and x minus 3, but I write it as x minus 3 squared. This trinomial here is, again, it's a perfect square. It factors to y minus 1 and y minus 1. I write it as y minus 1 squared. This circle is now in standard form. Remember, my center is the opposite sign, +3, +1. And this is my radius squared, so the radius is the square root of 8. 31, I said that you can skip. We didn't have to do that. That was lesson 11 that we didn't do. And this is just a really simple, easy proof of triangles. So I need to prove that these triangles are congruent. Basically, AB is congruent to AC from the given. CO and BO are both congruent because their radius is in a circle. And AO is congruent to AO because it's reflexive. Therefore, my triangles are congruent by side, side, side. And that's it. So if you have any questions at all, come to the extra help that I'm going to do. You can rewatch this. The answers will be posted. And that should be everything.